we will try to understand some basic concepts on graphs. So why we are learning graphs? Because graphs also we will be learn in other classes. As I said, we will use these graphs in how to solve problems in reductions, as well as we have some. It is very better to understand the basics of graphs. Okay, so we will discuss. It won't take much time, but we will try to spend little amount of time on graphs basically. So what is meant by graph? So any graph contains edges and vertices. So these points, these are the 3 vertices here and 3 edges are there in this graph. So graph is collection of vertices and edges, right? So this is basic idea of graphs. So we have different types of graphs basically. One is like loop graph. For example, if this is we have 2 edges here and 3 vertices, and if we will make this as this is loop. So we are starting from here and we are reaching here itself. So this is called loop, one of the type of graph. And for example, if we have one graph like this and we have like these edges, see these 3 edges are connected to same 2 vertices, right? These 3 edges are connected to same vertices. So this we will call it as multiple edge graph, right? Multiple edge graph, because it has multiple edges, but those are 3 edges are connected to same vertices. Okay, so this is another type of graph. And we have finite graphs. Finite graph means we will have finite number of edges and vertices in that graph. Okay. And now we will see what is meant by subgraph. So quickly I am explaining. These are not definitions of the graph, but I am just for our understanding, I am just explaining what is meant by the graph and what are the types and what are the things. But these are the not definitions. If you want to learn the definitions for your exam purpose, something purpose, you need to read books. Okay, so loop, multi-edge group, finite group, and we will have, for example, this is another graph. For example, in this graph we have 3 edges and 1, 2, 3, 4 vertices. So from this graph I want subgraph. So subgraph can be like this. So this part I cut here and I am calling this as subgraph, or I can make this as subgraph from out of this. So these are called subgraphs. So the subgraphs will derive from one graph, right? Okay. Let's, for example, we have another graph like this. So, okay, here how many vertices we have? A, B, C, D, E. These are the vertices, these are the edges. Okay. So, we are now, another graph is called induced graph. Induced graph means we will have one graph. Out of that graph we will create. Just imagine if I derive this graph from here, this what is previously we call it as subgraph, right? So to make this induced graph, this is only subgraph for this graph, but this is not induced graph because we are missing this line, this edge here. So to make this subgraph as induced graph, we need to add this edge also. Then only we will call this as induced graph. So we need to make sure every edge comes here while representing induced graph. So we learned a loop, multi-edge graph, subgraph, induced graph, and finite graphs, and what is meant by graphs. Okay. Now, for example, we will discuss about another graph called as connected graphs. For example, I have one graph like this. This graph name is A, and I have another graph like this. This graph is B. So these are disconnected graphs. These are disconnected graphs because there is no connection between these graphs. To make them connected, we can, from any one of the vertex, from here or here, we need to connect them. Then only this graph, we will say it as this. Now A and B are connected with this edge. This is one of the graph, connected graph. Now we will see what is meant by isomorphism. For example, I have one graph like this, rectangle or something. This contains 4 vertices A, B, C, D. And if I have another graph, so this is one vertex, this is another, this is another. This is how many are there? So 1, 2, 3, 4, 1, 2, 3, 4. But here I have 4 edges, but here I have only 3 edges. Let's say we will name this edge as A, this edge as B, this edge as C, this edge as D. Then if we name this as Z, X, Y, so these are not isomorphism because for A, Z is there, for B, Y is there, for C, X is there, for D, there is no edge. So to make this isomorphism, we need to make another edge. We need to make another edge here. X, Y, Z, A, P, R, and something. So now these becomes isomorphism. So now a graph without a cycle, we will call it as acyclic. We will call it as acyclic. A graph without a cycle, we will call it as acyclic. And forest is a acyclic graph. A forest is a acyclic graph. There will be no, for example, I have a graph like this. Different graphs scattered through, and those are not cyclic. Then we will call it as forest is an acyclic graph. A tree is a connected acyclic graph because a tree always will have branches and their branches are always connected, but there will be no cycle, right? If you observe any tree, any branch will connect to another branch? No, right? Only it will grows like this, but those won't connect. So that's why we will call it as a tree is a cyclic group. So when we doesn't have in a graph a cycle, then we will call it as a cyclic group. And forest is an acyclic graph. Okay. So a tree is connected acyclic graph. అక్కడికి వెళ్ళిపోండి, చెమట వచ్చేస్తుంది, వెళ్ళిపోండి బయటికి. So now we will learn about another graph called bipartite graph. Okay, so I am just pronouncing differently. So bipartite, bipartite graph. So if we have one graph like this, for example, if we have one graph like this, these are vertices, right? So from this graph, we need to make two different sets of vertices. We need to make two different sets of vertices. For example, this A, B, C, D, E, F. So for example, these are vertices, these are edges, right? So what is meant by bipartite graph? We need to make two sets out of these vertices available in the graph, n number of vertices. We need to make them as into two sets, so that those two sets will connect from one to another, but they should not connect in that set itself. For example, to understand ourselves, let's imagine this is set 1, this is set 2. Okay. For example, I took A as in one set, so I cannot take B and F, because if I place B here, what will happen? For example, I placed A, and if I place B, what will happen? There will be an edge in this between A and B. That means we need to represent like this. It should not, if we are representing like this, that means that is not bipartite graph. So whatever sets you are preparing here, those sets should be induced graphs. Basically, those sets should make them as induced graphs. So if I select A, I can't select B and F. So what does that mean? B will come here and F will come here. Now A, B, F are done. Now see, if I say C here, I can't keep D in this graph, so D will come here. So what left? E will be here. So now if you see AB, I can draw one edge here. AF, I can draw edge here. CE, C, where is E? Oh, okay, E also doesn't come here. So if it is C, it should make them as CE. Where is E? Sorry. This is D, this is E. There is no connection between. So now C to D is a connection is there, and D to E is a connection is there, and F to E is a connection is there. So A to F. So now see. Now in first set we have A, C and E. In second set B, F and D. So these two sets are induced graphs, basically induced sets of vertices. So if you observe, in these both sets we never drawn like this. There is no connection between any one of the vertices in this set 1 as well as set 2. Always there is a connection from set 1 or set 2, right? From here or from here, but not in that set itself, any one of the set itself. Then we will call it as bipartite graph, and these two sets are induced graphs. These will form an induced graph. So ACE, what is ACE? So this one is one set, BFD is another set. Okay. So this is called bipartite graph, and we will have another complete bipartite graph. In that case, what will happen? Everything will have A to B, B to C. Every node, every vertex will like this. Every node will have complete connections between all these sets. Then we will call it that as complete bipartite graph. So this bipartite graph is very much we need to understand properly. I hope you understand how to make these set 1 and set 2. These are induced graph. So now we will learn about vertex cover. Vertex cover. So now we know what is meant by vertex, right? In graph we will have vertexes and edges. So let's imagine we will continue the same example. Just let's imagine you are an emperor or king of your kingdom. Okay, you are an emperor of king of one kingdom, your kingdom ABC. So you need to protect this ABC kingdom from enemies. Okay, so this is your kingdom, and enemies are ready to attack, but you need to prepare your armies so that your entire kingdom will be covered. So if enemies comes from this side or this side or this side, your army should be ready to defend. Okay, let's imagine this is your kingdom and you need to place armies. Okay, how you will place, how you will cover your kingdom with your armies, where exactly you will place. For example, I place one army here. Let's imagine subset of my army, I place one of the army here. That means what? I am covering this edge as well as this edge, right? This edge and this edge they can defend, but this edge they can't defend because this is to come here. They need to cross this and come here. So this is okay. This army can defend A, B, D, but they can't defend C location. So we need to place our second army here. So army 1, army 2. So now what will happen? This army defending A, B, D, and this army can also defend C. Right? Now your kingdom completely covered by using vertexes. Right? This is called vertex cover. Vertex cover. How many vertex cover I require here in this case? 1 and 2. So I need 2 vertex cover points to cover my graph, my kingdom. Right? I hope everyone understands. So if you have any cyclic graph, that means if you have cyclic graph, then every time for cyclic graph you need n by 2 vertex points to cover your graph. If you have any cyclic graph, if you have complete graph means what? Complete graph means what? See, for example, I have 2 vertexes, then this is complete graph. If I have 4 vertexes, this is not complete graph because everything should be connected to each other. These 2 things are not connected, so we will make them as connected. But these 2 points, these 2 vertexes are not connected, so we will make them as another connection, establish another connection. So now this is called complete graph because every vertex connected to each thing. Right? You understood that? See, here previously we doesn't have these connections. Now once we establish these connections between these vertexes, this became complete graph. So for complete graph, how many vertexes, if this is your kingdom, how many vertexes you need to cover this kingdom? You require n-1 vertexes for any complete graph. Okay? Now we will see how many vertexes we require for cyclic graph. Previously we discussed about complete graph, how many vertexes we require. Now we will see, this is cyclic graph, how many vertexes we require to cover this kingdom. So here we have 1, 2, 3, 4, 5, 6. So for cyclic graph, we required n by 2, right? N by 2 nodes, n by 2 vertexes. Let's try this. For example, if I place here my army, so this one and this one will be covered. Okay? So now I need to place another army here so that this will be covered and this will be covered. But to make this cover, we need to place another army here or here. So now how many nodes? This one, this one, this one. So 6 by 2 equals to 3. 1, 2, 3. For example, if I have another node G, then how many? 1, 2, 3, 4, 5, 6, 5, 6, 7. 7 nodes by 2. This is ceiling. We need to calculate of 7 by 2 calculate. So this is how for cyclic graph we need to calculate vertex covers. So now we will try to understand another concept, maximum independent set. Maximum independent set. For example, if I have one graph and I identified this is set of my vertex cover points, So this section represents vertex covers. What are the vertex cover? What we discussed. So the remaining things will comes under this. This will represent maximum independent set. Okay. For any graph, once you identify the vertex cover points, vertexes, then remaining things will comes under maximum independent set. Okay. For complete graph, the maximum independent set is always 1. So we will represent it as alpha g. Alpha g is maximum independent set. So maximum independent set for complete graph is always 1. Okay. Once you calculate, identify vertex cover points, vertexes, so remaining things will come under maximum independent set. So once you identify maximum independent set, then remaining vertexes comes under vertex cover. Okay, vice versa. If you identify this, we can identify this. If we identify this, we can identify this. So for complete graph, alpha of g is always 1. For complete graph, vertex cover is what? How many vertex cover? Yes, n minus 1, right? Previously we discussed. For cyclic graph, it is n by 2, right? So once you identify, then you can identify max independent set. Okay. So for cyclic graph, it is alpha of g equals to n by 2 if it is even, or floor n by 2 if it is odd. So this is for maximum independent set. Okay. For complete graph, your maximum independent set is always 1. Once you identify vertex cover points, the remaining things are your maximum independent set. Okay.